Hello everyone, my name is Mr. Wilson, and today we're going to talk about chemical reactions and the collision theory. I'm going to talk about the factors that affect the rate of reaction. The first is temperature, and as you increase the temperature, the rate of reaction increases at a rough approximation of, for every 10 degrees Celsius rise in temperature, the rate of reaction doubles. But there may be different types of rate of reactions, like some might double at 9 degrees Celsius or 11 degrees Celsius, and the number of degrees needed to double the rate will also change gradually as the temperature increases. The second is concentration. For many reactions involving liquids or gases, increasing the concentration of the reactants increases the rate of reaction. In a few cases, increasing the concentration of one of the reactants may have little noticeable effect, but there might be a greater effect with another reactant. Then concentration. Okay. The third is surface area. Surface area is the area of matter that can make contact with another reactant. It can be increased by making the size of the reactant smaller. Increasing the surface area means you increase the number of molecules in a solid that are able to react. This allows for more room for more collisions to take place. If you decrease the surface area, less molecules are able to react and the rate will decrease.
The last two effects on rate of reaction are catalyst and pressure. First, we'll go over catalyst. So this is a real-world example. If you have a stack of papers that you need to be stapled, and you have 5 or 6 of them and 5 people in your group, then you need another person to speed up the process, so 6 people and 6 steps would speed it up. A catalyst is a substance that speeds up a chemical reaction, but is not fully used up in the reaction. That was an example, because you're not really using up anything, you're just adding to it to help it be more effective. Next is pressure. Pressure is the continuous chemical force exerted on or against an object. So if you have gas in a bottle or some object, and you barely have any force pressed onto it, there will be more room and less room for collisions to occur. But if you had put more force on it, then you would have more collisions occur. So as pressure increases, the gas molecules can and will have more collisions, increasing the rate of reaction. That's it.
Okay, and for a reaction to happen, the particles must have effective collisions, and the particles must have enough energy and collide at the right angle. Okay, and there are different types of chemical reactions. There are single replacement, there's double replacement, there's synthesis, there's combustion, and there's decomposition. Those are the 5 types of chemical reactions. Okay, how they relate. Okay, according to the collision theory, there are 2 ways to increase reaction rates. Increase the frequency of collisions and increase the fraction of collisions that are effective. If you speed up the particles by increasing temperature, there is a greater likelihood that they will bump into one another and the reaction rate goes up. If you increase the concentration of the particles in the solution, or you increase the surface area, now there are more particles to bump into and the reaction rate goes up. Adding a catalyst makes the collisions that do occur more effective by lowering the activation energy needed for the reaction. And that's collision theory.
Hello, ladies and gentlemen. Today we'll be learning chemical reaction graphs. A chemical reaction graph is used to measure the amount of time it takes for a reaction to occur over a set periods of time. And this is where your reactions are going to be. See the label 1, reaction 1, 2, 3, 4, 15 minutes, 30 minutes, 45, 60, 75 minutes. As you climb, it's reacting, and it stops at about, this is from reaction 1 to 2, that's the initial reaction. Second, and it has a flat line, and it's reacting again. Flat line some more, and it reacts, flat lines. And this is all over a period of 75 minutes. And this is basically how you do a chemical reaction graph.
Okay.